Hey everyone, and welcome to lesson 4. I want to apologize for lesson three's video not having sound. If you attended the class online, you got most of the information. However, if you were not able to attend, I'm going to go over briefly what we found in lesson 3 so that you can complete the work. The overall summary is that Earth gets 95 or more percent of its energy from the sun. And energy is the ability to make something change or move. So when we look at things like the solar ice, the polar ice caps, and it going from solid to liquid, there has to be some type of energy being transferred to this ice to make it change from solid to liquid. That change comes from there being more sun absorbed into the Earth's systems. Now, we also discussed that a lot of people make the claim that factories and cars and humans and everything we're doing on Earth is creating to making the Earth warmer. But the truth is it's not adding to the amount of energy on Earth. It's repurposing the energy that's already here. So if there's going to be a change in temperature on Earth, it's not going to be from adding heat from factories, people's homes, and cars, but there's going to be an adding of absorption of energy from the sun. So we concluded, in the last lesson, that there must be something going on in the gases in our atmosphere. The gases in the atmosphere can be put into the atmosphere from human or natural causes. So we're going to look at which which gases on Earth would cause more absorption of sun today. And we're going to look later on in chapter 2, what activities do humans do that would add to the amount of gases in our atmosphere. So today we're going to test the changes in the atmosphere. And while we begin, you're going to go on to Amplify. This question is on the Amplify website. So when you press pause, answer this on the website. And it says the atmosphere is about 480 kilometers, which is 300 miles thick, and surrounds Earth. For comparison, the size of New York is close to 600 and 700 miles from the top to the bottom, depending on where you're starting and ending. So it's not that far space, but from the ground all the way to the end of our atmosphere is 300 miles on average. So what is the atmosphere made out of? And if you know what it's made out of, do you know the particular elements that would also make up the atmosphere? At this time, press pause, and then when you come back, we're going to continue past this point. Okay, welcome back. So we're going to go into the simulator, and we're going to look at the mixture of gases that the simulator projects for us to complete. So I'm going to exit out of the slideshow and go right into, if it lets me, and go right into the Amplify website. Again, this is where you should have answered the question for this. What is atmosphere? And it's the mixture of gases surrounding the planet. Now we're going to look again, like I said, in the simulator for what types of gases and how these things react to the sun's absorption. So once you press your answer, make sure you click Save and Continue, hand in, and then we should go on to introducing claims chart. Now, we're going to look at different things and claims, but I want to remind you guys that the unit question, what we're focusing on is why is ice on Earth's surface melting? But for today's investigation, we're going to look at what kinds of changes to the atmosphere could affect how much energy is absorbed by Earth's surface. So we know that the sun is what makes us hotter or colder. The amount of sun that we absorb makes it hotter or colder. And right now, with ice melting, we can assume that the global temperatures are going up because ice melts when it's warmer. So we're going to look at the gases to find out what's going on in our atmosphere to figure out what's going on. So we're going to run all of the tests on all of the gases, but the first one that they introduce is nitrogen dioxide and carbon dioxide. We've talked a lot about carbon dioxide in the past when it came to our bio unit on ecosystems. So we already know that part of the atmosphere, but we're going to look at the other gases too, because there might be other effects or other causes that might have the effect of melting ice. So what we're going to do is let the sim run for 20 seconds. Make only one change per test. So first we're going to do the nitrogen test, and then we're going to do the carbon test. Make only one per test. When increasing, set the gas at 500 part per million. ppm is part per million. When decreasing, set the gas at 0 part per million. So they asked us to go to the extremes, the highest and lowest that the models allow. Run the test until the timer reaches 40 seconds. So this would mean that the first 20 seconds is no change, and the next 20 seconds is going to be with change. Observe the temperature, the amount of ice, and the glow of the absorbed energy. View the graph to observe changes in temperature, surface, and absorbed energy. Record your results. So again, right now we're going to start with nitrogen dioxide. And it says when increased, energy absorbed by the surface blank, temperature blanked, and the amount of ice. So we're first going to increase and then decrease. And we're working solely with nitrogen dioxide. So I'm going to open up the simulator. Sorry for the load. I'm not sure why it's taking so long, but I'm going to give it another second or two to load. All right, there we go. So again, we're looking at nitrogen dioxide. So we're going to, it tells us to leave on for 20 seconds. So right here, you'll see the time, the temperature, and the energy entered and exited. So I'm going to play this for 20 seconds. Again, I'm going to play this on twice the speed just to get to the data point. All right, stopped it right at the 20-second mark. Now the first step, it says to increase the nitrogen dioxide, and that is the purple one. I'm going to make all of them visible just so that it's pretty on the screen. I'm going to increase to 500, and then I'm going to see what happens. Again, I'm waiting for the time to get to 40 seconds so that each section had 20 seconds or 20 time units. All right, so let's take a look here. The surface ice and the absorbed energy. At this point, it seems that before and after, so before, right before, the ice was at 50%, and right after, still at 50%. It seems that the temperature is also staying pretty stable, and the amount of sun being absorbed, again, seems pretty stable. So I'm going to go back to this part. When I increase the nitrogen, energy absorbed by the surface did not change. Temperature did not change, and the amount of ice did not change. So adding more of this substance didn't actually change anything with the ice. There was no change. So I'm going to go back and I'm going to reset and see what happens when I decrease it. So again, setting it to 2 times. I've done nothing to it. I'm going to let it play for 20 time units. Sorry. All right. Now I'm going to decrease all the way down to 0. And again, let it play for another 20 time units. Let's look at the chart. Again, I'm adding the surface ice. And here, before, again, the ice accounted for 50%. Whereas after, so right here, you'll notice right here, it lets me know that I added, or I subtracted the nitrogen. It didn't change it either. So again, this had no change when I decreased it. Now, I'm going to go and do the same thing for carbon dioxide. I'm going to reset. I'm actually going to, since we know how to use the program, set it to 4 and let it play for 20 units. It's okay if it's a little over. I'm going to go to 500 and then let it go out for the rest of the units. And let's take a look at the graph. When I increase carbon dioxide, which would have happened right here, so I'm going to put it on the before and after. When I increased the carbon dioxide, the amount of energy absorbed, the yellow line, increased, but the amount of ice decreased significantly. So when there was more sun absorbed, the ice melted, which makes sense. So the energy absorbed increased. The temperature, so let's go back and take a look at that temperature. It started at around 14 and ended at 19.9. So that also increased. And the amount of ice decreased. We're going to play this again with removing carbon dioxide. Set to 0. 4 times. Sorry, temperature 14. Going all the way to 20 to see what goes on. And then I'm going to take carbon dioxide and set it to 0. Continue playing until we get to 40. And let's take a look here. what happened was when there was more ice, the ice goes up, but because the temperature went down. So if we got rid of carbon dioxide, the temperature on Earth would decrease. And it goes all the way down to 10 degrees Celsius. So when we decrease carbon dioxide, the energy decreased, the temperature decreased, but the ice increased. Save and continue. We're going to continue this again for sulfur first and then to methane. Play to 40 times the units. We're going to play with sulfur first, increase it to 500. Pause. Temperature went significantly down. So when we increase sulfur, less sun was absorbed and more ice. So this has an opposite effect as carbon dioxide. So when we increase sulfur, there was a decrease in energies and a decrease in temperature, which makes sense, but the ice definitely increased. I'm going to switch it, going back the other way, which I assume is going to have the opposite effect. Going the opposite way. All right, let's take a look at the graph. And again, my prediction was right. When we got rid of sulfur, we absorbed more sun, which would mean that the ice went down. More heat from the sun goes down. So, when we decrease sulfur, energy increased, absorption increased, temperature increased, and ice decreased. So this sulfur has the exact opposite as carbon dioxide. And now our last one is methane. So we're going to do this one quickly. We're going to take the methane, go all the way up. And we see that when we increased methane, we increased absorption, which increased heat. So there was an increase, and less ice. And for the final one, which we can kind of predict that it's going to be the opposite, if we get rid of methane, what will happen? Take a look at our charts. And just as predicted, when we got rid of the methane, the temperatures, the sun absorbed less, and that the ice increased. So again, when we decrease methane, the energy decreased, the temperature decreased, and the ice increased. Here's where you want to press save and continue. So if we go back to the claim that a change in any gas in the atmosphere affects energy absorbed by the surface in the same way. So, no, we realize that some of them will have opposite effects and some will actually have zero effects completely. There will be no effect by their change or no significant. So I would have to disagree with this claim. I would refute this claim saying that not all the gases had the same outcome. So CO2 increased temps when there was more. Where, let's take a look back at our data. Methane increased when we increased, there we go. So, but let's take a look at our first set of data that nitrogen had no effect. So if I go back here, where nitrogen had no effect when increased or decreased. So right away, we know that this claim can't be true because every gas is going to have a different result. Now, in the atmosphere, these gases are not individual or separated. They are all mixed together, but there's a percentage that of each gas inside the atmosphere, which is what we're looking at, changes in the percentage of these gases in our atmosphere. So right there, I'm going to press hand in. You don't need to add pictures. And let's go down to the last part. So this part, I want you guys to complete on your own, and I'm going to be grading this. Again, you should try to use the CER model where there's a claim, evidence, and reason. And it says with a partner, but you're going to be doing this on your own. What kinds of changes to the atmosphere could affect how much energy is absorbed by Earth's surface? Now, we know that the change that could affect the atmosphere is an increase or decrease in certain types of gases, because these gases would change how much the sun absorbs. So I want you to use the claim, evidence from the simulator, and reasoning. Talk about absorption of energy and how more energy being absorbed would increase the temperature. And increase the temperature would change the ice. So what kinds of changes to the atmosphere could affect how much energy is absorbed? And it has to do with which gases. Thank you guys, and sorry about the video earlier this week.